Okay, so to start this lab, we need to heat up our crucible in case there's any residue on the crucible. So of course, what we do is we turn the gas on, full blast, air inlet ports are closed on the Bunsen burner, and we light the Bunsen burner with a match. Now I open the air inlet ports just enough so that I get a nice inner blue cone. There we go. So that nice inner blue cone means that we have a really, really hot Bunsen burner flame. And I'm just going to heat that up for a few minutes in order to clean the Bunsen burner, or excuse me, in order to clean the crucible. Okay, so now I will shut the gas off. In order to let the crucible cool, I'm going to move it over to the desiccator. And I move that over first the top of the crucible, then the bottom of the crucible, and I let that cool for several minutes inside the desiccator. Okay, so now that the crucible is cooled, we will remove it from the desiccator and onto the balance. And we need to record the mass of the crucible and balance together, the crucible and lid together, 20.955 grams. And I will use a micro spatula, and I will add approximately 2 grams. So bringing it to about 24 grams of the mixture. There. Put the lid back on the container. Transfer, so the mixture and crucible is 25.02, let's say 2 or 2.1 grams. And we will transfer both back to the Bunsen burner. Make sure that the lid is only slightly ajar. We want there to be room for the gases to escape, but we also don't want any splattering. Twist the Bunsen burner so that the air inlet ports are closed again. Turn on the gas. Bring it to the side. There it goes. Okay, air inlet ports open again till I get a nice inner blue cone. There we go. And once I have a nice inner blue cone, I'm going to let it heat for about 5 minutes. Okay, so this has been heating about 5 minutes. We shut off the Bunsen burner. Now transfer it one piece at a time to the crucible, to the desiccator in order to cool. Cooling, because the next thing we're going to be doing is putting it on our balance here. We need to make sure that it's completely cool, otherwise we will damage our balance. Okay, so now we will take the crucible and the lid out, and we will record its mass. It has gone down. It's now 24.242, let's say. So, oh, maybe not. Let me see. Let's call it 24.240. And what we'll do is we're going to put that back on the Bunsen burner. And we'll heat it up again, hoping that after heating it up another 5 minutes and then cooling it, that it weighs the same. It has the same mass. And if it has the same mass, then we can assume that we have decomposed all of the sodium hydrogen carbonate. Open the air inlet ports again. Okay, we'll heat this up for another 5 minutes. Okay, let's hope that this will be confirmation that we have decomposed all of the sodium hydrogen carbonate. So we're going to put this back into the desiccator, let it cool again for a few minutes. Okay, let's see how we did. Slide this off, carefully transfer each piece at a time. I want to say before it was 24.242, 24.237. Ugh. It's probably fine, but you know what? One more heating can't hurt. So we'll put it back on because we would rather have good data than bad data. Okay, we just heated it and cooled it, 24.234. Let's do it one more time, see if we can get that exact same thing. Okay, 24.232 sounds good to me. Looks like we have a constant mass. Now we just dump all this into the trash, clean up, and work on our calculations. Okay, so here's our data table for the percent composition of a mixture lab. So what we did is we took the mass of an empty crucible and lid, that's 20.955. We added a mixture of sodium hydrogen carbonate and sodium carbonate, and we added more than 2 grams. We added about 4 grams, so 25.022 grams. And then we heated it, and we heated it numerous times to make sure that all of the sodium hydrogen carbonate was decomposed into hydrogen gas and, into water and carbon dioxide. And we did that, and the mass kept going down a little bit, so finally we got a constant mass of 24.234 grams. So the first thing that I want to do is think about what actually happened in this lab and writing out a balanced chemical equation. We're going to do some stoichiometry. Stoichiometry means we have to have a balanced chemical equation. So I'm going to I gave in the pre-lab the unbalanced chemical equation for the decomposition of sodium hydrogen carbonate or sodium bicarbonate. So this would be a solid, and as we heat this up, it decomposes into sodium carbonate, which is still a solid, and water, which is going to be a gas at that temperature, and carbon dioxide, which is a gas even at room temperature. So balancing this, we haven't done this for a while, but right off the bat, I can see 1 sodium on the left and 2 sodium on the right. So if I put a coefficient of 2 there, does everything else balance? And actually, I think what you will see is that everything does balance. I would get 2 hydrogen on the left, and there's my 2 hydrogen on the right. 2 carbon on the left. There's my 2 carbon on the right. And 6 oxygen on the left, and there's 3, 4, 5, 6 oxygen on the right. So this is balanced. And the other piece of information that I know at this time is the mass of the gas that has been driven off. So if I take from the data table that we started out with 25.022 grams of mixture, and then at the end, I had 24.234 grams left, then that must mean that the difference between those two is the mass of the gas that evaporated, that escaped. And when I subtract those two, I get 0.788 grams of gas. Just a note on significant figures and rounding, because it's a subtraction, I'm only worried about decimal places. So 0.788 is my answer. So now I've limited my number of significant figures to just 3. So this is grams of gas. Through stoichiometry, I can sort of figure out that if I could figure out that if this is 0.788 grams, if I could figure out how many moles this is, I can then go back and figure out, well, if 1 mole of gas that escaped must have come from 2 moles of sodium hydrogen carbonate. And I know that's weird to think 1 mass of gas, but if I think of if I think of the water and carbon dioxide kind of together, because I don't know how, of the missing mass, I don't know what is water and what is carbon dioxide. So what I'm going to do is just call it gas and say that instead of hydrogen, instead of saying, we added or what was released was water vapor and carbon dioxide, I can just say 1 mole of gas. And how much did that 1 mole, or what is the molar mass of that gas? Well, if I think of it as 2 hydrogen, so hydrogen times 2, and then oxygen, how many oxygen are there? Well, 3. How many carbon are there? 1. I would get that the molar mass of all the gases together would be 62.026 grams. That is how many grams there are for 1 mole of the gases. So I'm talking about the gases here together. So let's take that, and let's take our 0.788 grams of gas lost. And this is kind of weird. That 1 mole of our gases lost had a mass of 62.026 grams, because the gas that was lost was a combination of water and carbon dioxide. So I'm adding them together. When I do that conversion, I get 0.0127 moles of gas lost. Again, keeping 3 significant figures, but I'm not rounding in my problem. Now, according to the balanced chemical equation, 1 mole of gas must have come from 2 moles of sodium hydrogen carbonate. So I take that 0.0127 moles of gas, and it meant 2 moles of sodium hydrogen carbonate must have decomposed for every 1 mole of gas. And doing that out, I figure that it must have been, 0.0254 moles of sodium hydrogen carbonate. That must have been how many moles of sodium hydrogen carbonate were in the original mixture that decomposed. So what I want to find, think about, we probably should have done this at the beginning, but, circle the do, underline the clue. What do I eventually want to find? Well, if I want to find the percent composition of the mixture, I want to be able to get the mass of the NaHCO3 over the mass of the mixture. And so I'm kind of partially there. So right now I have 0.0254 moles of sodium hydrogen carbonate. And I'm going to convert that to grams. 1 mole of sodium hydrogen carbonate is 84.008 grams. When I do out that calculation, I get 2.13 grams of NaHCO3. That's perfect. So now I have the top, 2.13 grams of NaHCO3. What was the mass of the mixture that I started with? Well, we're going to have to go back to our original data with that. If we go back to our original data, and this is the mass of the empty crucible, and this is the mass of the crucible and mixture. If I subtract those two, I will get the mass of the mixture, and it was 4.067 grams. That's the mixture that I started with, 4.067 grams. So now I can just divide that by 4.067 grams of the mixture and get my final answer. So 3 significant figures. I'm going to say that this mixture was 52.48, so 52.5% sodium hydrogen carbonate. And that must mean that the rest of the mixture was the sodium carbonate. I can just basically figure that out by knowing that the mixture must have been a little bit of both. I mean, the mixture was a little bit of both. The other way that I could figure that is by actually figuring out what would be the mass of the Na2CO3 by just subtracting the mass of the mixture, 4.067 grams. Well, subtracting from the mass of the mixture, the mass of the sodium hydrogen carbonate. And if I do that, I would get that it would be 1.937 grams of the Na2, the sodium carbonate, Na2CO3. Divide by 4.067 grams. We're going to wind up getting, hopefully, what 100 minus that is. So divide that by 4.067, and we get 47.6%. Why doesn't it equal exactly 100? Rounding. Basically, the idea of rounding. These two numbers, do they add up to fairly close to 100%? Yes. I have to say I did not go back and use the full number from 2.13. So that's how we can take the data from the data table and figure out how to get the percent of hydrogen carbonate and the percent of sodium hydrogen carbonate and the percent of sodium carbonate from the mixture. It's a lot of calculations. It's a lot of stoichiometry. And now what you need to do is take the data table that I have emailed you and your partner and go through and do these calculations yourself. You can just do them on a piece of paper because I don't think you have much room in the lab. And then there are a whole set of practice problems, 1, 2, 3, 4 for you to try. And there's a lot of the same type of stoichiometry problems. So give those a try.